For session 7.6 improper integrals, we will have two videos. In the first video, we will study one type of improper integrals, that is, when the limit of integration is infinite. In the second video, we will study another type of improper integrals, that is, when the integrand becomes infinite. Let's talk about the case when the limit of integration is infinite. So we start from an example. Example 1, evaluate the integral from 1 to infinity 1 over x squared dx. You see this, the upper limit is infinity. We don't know how to handle with this yet, but we can do this one. The integral from 1 to b 1 over x squared dx. For this integral, this is equal to the integral 1 to b x to negative 2 dx. Then this is equal to negative x to negative 1, 1 to b. Then this is negative 1 over b minus negative 1. So this is negative 1 over b plus 1. So now we let b goes to infinity. B goes to infinity. So this one goes to 0. So we have this then goes to 1 as b goes to infinity. Right? So now we see the integral of 1 over x squared from 1 to infinity dx convergence. And in this sense, we say the integral of 1 over x squared from 1 to infinity dx is equal to 1. If we look at the graph of 1 over x squared, we have suppose this red curve is the graph of the function y is equal to 1 over x squared. And suppose x is 1 is here, then this is 1. So the integral of 1 over x squared from 1 to infinity is the area of this part. This is the integral from 1 to infinity 1 over x squared dx. So we see that we have a region which is infinite in extent, but whose area is still finite. We have a region which is infinite in extent, but whose area is still finite. So now let's introduce the definition of improper integral. So we let f(x) be defined for x greater than or equal to a if the limit of the integral of f(x) from a to b as b goes to infinity exists and is finite. We say the integral of f(x) from a to infinity converges. In this case, we define the integral of f(x) from a to infinity is equal to limit of f(x) from a to b to infinity. Otherwise, we say the integral of f(x) from a to infinity diverges. The convergence or divergence and the definition of the integral of f(x) from negative infinity to b dx are defined similarly. This is the definition. So next, let's look at an example. Determine for which values of the exponent p does the integral of 1 over s to p from x from 1 to infinity dx converge or diverge. Let us first consider the case where p is not 1. If p is not 1, now we look at the integral of 1 over s to p x from 1 to b dx. Look at this integral, then we let b goes to infinity. So this is the integral of s to negative p x from 1 to b dx. This one, its antiderivative is negative p plus 1 x to negative p plus 1, then x from 1 to b. So this is equal 1 over 1 minus p b to 1 minus p minus 1. If p is greater than 1, then 1 minus p less than 0 and b to 1 minus p, this goes to 0 as b goes to infinity. And in this case, we have the integral of 1 over s to p x from 1 to b dx converges to 1 over 1 minus p 0 minus 1. This is 1 over p minus 1. And so the integral of 1 over s to p x from 1 to infinity converges, and the integral of 1 over s to p 1 to infinity dx is equal to 1 over p minus 1. This is the case if p is greater than 1. Now let's look at if p less than 1. Then 1 minus p is positive, and b to 1 minus p goes to infinity as b goes to infinity. In this case, the integral of 1 over s to p x from 1 to b is equal to 1 over 1 minus p b 1 minus p minus 1. This goes to infinity as b goes to infinity. So the integral diverges. Finally, we consider the case p is equal to 1. So the integral of 1 over s, p is 1, this is 1 over x, x from 1 to b dx. This is equal to ln the absolute value x, then x from 1 to b. So this is ln b is positive, right? The absolute value b is still b. So ln b minus ln 1. Ln 1 is 0. So this is ln b. If b goes to infinity, ln b goes to infinity as b goes to infinity. Thus, we have the integral 1 over x as from 1 to infinity diverges. Then we talked about all the cases. P is 1, P less than 1, and P greater than 1. So now we summarize what we get. So this is improper integral, the integral 1 over x to power p x from 1 to infinity dx. This integral diverges for p less than or equal to 1, convergence, and has value 1 over 1 minus p for p greater than 1. This example is important. So this is all about this video.